Welcome back to part 2 of our testing a claim about a population proportion. We went through, and as a quick super summary here, we did a hypothesis test using the traditional method and found out that we have enough evidence to conclude that the proportion of people who recycle now is greater than it was a year ago, and that was 25%. That was the traditional method where we drew this picture, found the critical value, found the test statistic, and saw where he landed in the critical region and reject H naught, or not in the critical region and failed to reject H naught. There is another way that we can come to our conclusion that we talked about in 8.1, and that is the p-value method. So let's set up the problem, but let's start over and pretend that we're starting over, and we'll do everything again. So we're going to do our requirement check. So we did have a random sample. Okay, we had a binomial, so we had a success as the person recycles and a failure as not recycle. Okay, and trials are independent. So we notice then that the probability of success would be a constant, and according to this, we'd think it would be 25%. That's our default assumption going in. And we found out that NP was 27.5 and NQ was 82.5, which are both way bigger than 5. So we can use the normal approximation to the binomial and use z-scores. Remembering again that X was 36, N was 110, and we computed P hat as X over N, which was 0.327, and we were given a 5% level of significance. Once again, we'd write out our hypotheses. We think that the population proportion is 25% based on what we know from beforehand, but we're putting on trial the claim that it is higher than 25%. So this will be a right-tailed test. And we find the test statistic, and hope it's not too big of a shocker, but it's going to be the exact same as what we found just a minute ago. So we'll find out that this guy is 1.87. But notice how the p-value method, I didn't draw a picture, okay? All I did was find the test statistic, but I didn't draw the bell curve. What we do now for the p-value method and how he's different from the traditional method is we take the test statistic, and maybe in our mind we draw the picture, and think about how much area would be outside of a test statistic of z equals 1.87, and outside would be to the right or away from the middle. So if I look up 1.87 on my wonderful z table, 1.87's z-score is, if I slide that down, you can see that 0.9693. Oh, but remember that that's the area to the left. So the area to the right would be 1 minus 0.9693. So that would give us 0.0307. So our p-value is 0.0307. So about 3%. So based on random chance, there's a 3% chance that we could get a random sample that would still have, or well, would be have an average, or sorry, a proportion that high just due to random chance. But that's still a pretty small number. And if we compare our p-value, 0.0307, against our alpha of 0.05, we see that it is less than. And if the p is low, the null must go. So we are going to reject H naught and write out our real world conclusion. So reject H naught. There is enough evidence to conclude that the proportion of people who recycle now is greater than 25%. Okay. All right. Now, no matter if we're doing the traditional method or the p-value method, we can get some help from our calculator. And if we were taking it from the top, we hadn't done all the extra work or haven't done all this previous work, we could set it all up. We still have all this from earlier, or well, all this that we could find out again, I should say. And it's going to be a right-tailed test. But if we have our TI 8384 calculator, we can get this test statistic without having to worry about all the parentheses and anything that might go wrong there, if we are careful. So we're going to turn on the calculator. Okay. And can we see that? There we go. We're going to go to the stat menu, the tests menu, and we're going to run the one prop z-test because we're dealing with one sample on a population proportion. We use the z-distribution, and this is a hypothesis test, not a confidence interval. So one prop z-test program. Again, it asks us for p-naught, which is basically our little p, just they use a slightly different notation for it. So we're going to type in 0.25. X, which is 36, and N was 110. And here is our way to tell the calculator what our alternate hypothesis is. And in our case, it's that the proportion is greater than 25%. And remember that P0, we told it, is the number 25%. So we want prop to be greater than 25%. So we're going to pick the greater than option here and hit calculate and write down what we see. Okay. So I will write that down right here. One prop z test. We find out that z equals 1.87. Oh, that's good news. The next thing is we find out p, which is the p-value, is 0.0306. It even tells me p hat is 0.327 and reminds me that n was 110. Okay, so you can see all of that still in there. Okay. Now we're going to take this and show you how we can use the calculator to solve this in both ways. So we do steps 3 and 4. If we do the traditional method, we're going to take and draw our bell curve. And 0, 1, 2, 3, etc. We'd find out that our critical value is still 1.645 from our table because we had a 5% level of significance on a right-tailed test. We would then take the information from the calculator, which tells us what our test statistic is, z equals 1.87, and that landed in the critical region, so we will reject H naught. Therefore, we have enough evidence to conclude that the proportion who recycle now is greater than 25%. Now, we don't know if it's 27 or 32 or 29 or anything, but we have enough evidence to say that it has gone up. Okay. So once again, that's using the calculator to help us do the traditional method. and notice that we got the exact same test statistic as what we did by hand. Now we could do it again, but using the p-value method. And once again, the p-value method is different because we don't draw the picture, we merely find the p-value. And so our p-value is 0.0306. Uh-oh, that's different from what we found from the table by hand. But the only reason is because we rounded our p-hat value to 3 decimal places. If we'd carried many more decimal places, we would have gotten 0.0306. But that is a very, very small rounding error, and we're not going to worry about that. And so we still compare that to alpha of 0.05, and we see that the p-value is less than alpha. If the p is low, the null must go. We must reject H naught, and therefore we have enough evidence to conclude that the proportion of people who recycle now is greater than it was 25 years or a year ago at 25%. Okay, we'll see you in the next video.